Good afternoon, everyone, and thank you for staying to what is the last presentation. I think we share the same goal here, because I want to get to the last slide, because the last slide is the big example that I want to spend a bit of time on. But I need to take you through a few steps first. So let's see if we can get there in the time available. What I want to talk, I've broken this up into three areas. I want to talk about what the demand is for broadband, what is causing the demand for broadband networks. I want to look at how we can deliver it, how we can supply it, and then how do telcos respond? Because I spend a lot of my consulting career trying to advise telcos on how to, what to do next, how to build these networks. So that's roughly what I have in mind. It's no surprise to any of us here that the huge data growth in the internet. The video is the biggest component of that. It's dominant in terms of the number of bits. Sometimes that's a problem, because how do we monetize that? But there's a couple of other big trends: cloud computing, things we've heard about today, the convergence on internet technologies. The problem is that there's shrinking margins. So the telcos have to move more bits for less money. So how are we going to do that? This is a couple of pictures from the two past inaugurations of Pope. First one is everybody's got little cameras. Second one, everybody's got mobile phone. This is the big story: smartphones. And to me, a smartphone, it may surprise you, to me as a smartphone is a way to carry around software. I've always viewed smartphones as a transport for applications. Even when I'm on a plane and I can't make a call, my smartphone is still useful to me. And this is the big story. It's portable software and how software's starting to dominate all aspects of our lives. And that's really the smartphone story. Coupled with that, there's a lot of other things going on. There's a lot more people coming onto the internet. There's a lot more innovation and entrepreneurship, creating new applications. This is really what the internet is. It's an innovation and entrepreneurial machine, and it's very hard to keep up with it. Telcos particularly, used to 10, 20-year planning cycles, completely the wrong pace of company to move into the internet business, and yet that's where they are. So there's a lot of things going on. For telcos, how do they keep up? How do they move rapidly enough in this changing environment? There's going to be a lot of other devices. Smartphones at the moment are everybody's favorite. We will be wearing and using a lot more individual devices. I don't know whether Google Glass is going to be successful, but things like it will work into our lives for sure, because they're just so useful. They will find ways in which to be indispensable. Interesting still, a lot of things are still circulating around Wi-Fi. It's very interesting. That's not going away. It's just a really useful standard that's being built into everything from thermostats to door locks. So the way it's going then is it'll be Wi-Fi for fixed and Bluetooth for mobile. That seems to be the set of technologies. Lots more data. More spectrum, more data. Just looking on the left-hand side, we see that base stations are going to move into the gigabit, the gigasite era. It's absolutely mandatory that all of these things are fed with fiber. There's going to be no other way to do it. So right there, you're going to have fiber straight into the back of the base station, and then you've got wireless. This is the future for all of the mobile operators. In the old days, mobile networks talked about coverage. It was the big thing. We've got a national network. We cover 95% of the UK, whatever. It was a key hygiene factor. If you didn't have coverage, you couldn't use the network. This is no longer going to be the most dominant thing. People want not just being able to make a phone call, but they need to be able to use the data at a usable bandwidth. You can't have a mobile network where it gets so slow in certain places that you can't do the thing you want to do. It's no longer going to be acceptable. So this idea of no edge is a problem that the mobile operators need to fix. You can't just put up a couple of big, powerful transmitters and hope that's going to solve the problem. It's not going to do it. So no edge is the de facto requirement, which brings me to kind of the first summary slide that I have. So we've talked about all the requirements then. We've got all this data. We need to move it around really efficiently. for less and less money each time. We've got all these converged services, software was moving around. We want our mobility. We want mobile phones and so on. In fact, most of the things we want to do are probably using a wireless link. So even if I'm sitting at home, I'm on the Wi-Fi, I'm on the 3G, it doesn't matter. I don't want to be tethered by the wire. So we come up with our fundamental design criteria for modern networks is everything's going to be fed by fiber because that's the only way to move the bits, and the last link is wireless. Only one wireless because that's the only way to give you the performance. So fiber plus one wireless is going to be the new network design principle. Okay, so that's very quickly all the things that are driving on the requirement side. Let's see how we're going to supply all of that. This is a key slide. I live in Singapore. What do I got in my home? I got fiber to the home that I can get multiple operators to supply with 1 gigabit service for very, very little money. I've got cable broadband that I currently use up to 100 megabits. I've got DSL, 20 megabits. I've got 2G, 3G, and 4G networks from at least 3 operators. There's an overlay WiMAX network. I am covered multiple times with networks. I'm absolutely swimming in bits. And this is the way telcos have built themselves out. Networks on top of networks, overlays on top of overlays. There's a couple of problems with that. It's a bit of a waste. There's a lot of infrastructure there. Competition is one thing, but all those things have to be paid for by us consumers. And secondly, how we're moving all those bits around. So the key point here is that it's going to be fiber to all of these different devices, but there's going to be more and more ways in which we're going to access the network. We need to flatten it so that we can get access to fast connections wherever we are, no matter which operator we're using. So this idea of flattening it out, getting rid of all the old stuff and reducing it down to a set of technologies that gives us what we want, which is high-speed data mainly, anywhere we are. So that's the basic premise of this talk, is how do we get to that? Here's one of the problems. This is actually UMTS 3G. This is what happens when the cell gets more and more loaded. It does well for a while, and then it collapses because of all of the extra signaling data that's going on. Crowded cells collapse in 3G. LTE, I admit, is better. But this is a problem, and you simply can't fix this any other way than adding more cells. There's the only way to do it because of this fundamental problem. So we end up with the idea of small cells. Femtocells, picocells, nanocells, whatever you want to call them. There's no fixed name. You need more infill cells. How do we do that? This is a kind of a taxonomy of small cells. There's no agreement about what form factor they are, what are they called, what are their capabilities. And that's one of the problems with small cell up till now, is that various people have been pitching them in certain ways, and there's been no commonality. But they're now reaching a point where people go, yeah, you're right, yes, we do need them. We can't avoid them any longer. For the last couple of years, they've been seen as fixing the 5 bars problem. You've got a rural farm or something, he gets no mobile coverage, you give him a femtocell, he gets 5 bars inside of his house, he's a happy customer. That's what they're doing in Australia, for example. Now we're going to see that this will be a routine way to provide all of those interim base stations. So what they're saying now is in the next few years, 90% of all of the so-called base stations of any size in major markets will actually be small cells. That's the numbers we're talking about. Instead of having 50, 60,000 macro cells, there will be maybe 10 times that number of smaller cells. And that's the way it will be delivered. How is that going to happen? It's because we're going to integrate them into things we already have, like set-top boxes and home routers, not as a separate device anymore. So this is starting to come together now. On the right-hand side, this is the key point. What are the technologies? At the moment, it tends to be 3G. That's going to be quickly replaced by 4G, because LTE, because that's the way everything's going, and Wi-Fi. So we're going to have set-top boxes, home routers with an LTE femtocell and Wi-Fi. That's going to be backed up with our fiber broadband. That's going to give us everything we need. That's going to allow you or even your neighbors to home in onto that small cell and give you 5 bars, full speed coverage to allow you to watch video wherever you want. That's how we're going to do it. Okay. Outdoors, this is an interesting concept. I've borrowed directly from the website. VPole, Vancouver Pole, it's a concept design. The idea is it's a lamppost with very small software-defined radios in it. We can get radios this small now. They don't have to be big boxes. The point is that this is the kind of thing I can see working, because there's no not in my backyard syndrome. People don't mind having lampposts that look like this, that are useful, because that could give you multiple operators, multiple radio standards, LTE, Wi-Fi. We can solve all the problems that, for example, if you've got a subscription for broadband at home, it automatically gives you access to the Wi-Fi network as a guest. We can solve all these problems now. And with fiber rolling out down all these streets, it's very easy to put a fiber into a lamppost. That's no longer a big issue. So this is the way we're going to see the world. All this telecoms infrastructure is going to be small, spread around on a street level, almost invisibly. You won't have to go looking around and stand next to something. It will just work. But it's the only way we're going to solve this data crunch. So that's what it's going to look at outdoors. Indoors, this is a Huawei product, but the idea is very simple. So for shopping malls, stadiums, and so on, you want to get everybody onto a small cell network within the facility, but you don't want them hopping around between different networks, going on the macro network, on the micro. You've got to integrate at this level the small cells with the macro network. So this is what the Huawei product does. This actually the same base station controller drives the small cells as well, and so it's a single RAN. It's a single network, and that's the way you want to avoid a lot of the performance issues you get with trying to drop in small cells into public spaces. It'll be LTE and Wi-Fi again, common elements now that we see backed up with fiber. So that's the end of section 2. I'm kind of rushing because it's the section 3 that's really going to be the interesting one for me. So from a business point of view, and this is what I do, business consulting, what do I see for my clients? Well, they need to get all the costs out of the business, so a key factor for them is OpEx. Getting the OpEx down is absolutely crucial. And choosing the right technologies that gets all the costs out of the business is the only way they're going to stay in business. At the same time, they need to build up a set of services. Everything is becoming internet technology, so they've got to get themselves into kind of the internet business. They've got to either cooperate or compete with the OTT players. Either will do, depending on how effectively you can do it. And you need a network that you can rapidly deploy new services on and control the traffic flows so that you can give people the data they want. So all this talk we've heard about SDN, that's all the kind of stuff we need. We need to be able to move the data around, set up new flows, set up new services, and move at the same speed as the internet guys are moving at. That's what we need from our network. So agile provisioning, on demand, managing the customer experience by knowing what the bits are doing, and driving the network to meet performance standards. Okay. Technologies then, fiber, LTE on the access, maybe some gigabit microwave. At the moment, we're going to need that for the next little while, but fiber as soon as you can roll it out. The OSS needs to support that in a single box. All the things I've just said about agility, you don't want to be messing around with lots of boxes. You need a converged OSS that will do all of this for you, not just segment by segment, but across the network end to end. It's the only way we can do this. If you can do all your network rollouts with zero touch, meaning you can just basically send the consumer the box, it plugs in and away it goes, self-provisioning. These are all the ways in which we get the OpEx out of the business, and we give people what they're really looking for, which is very high level of customer service. So it just works. And a lot of the things we talked about in terms of managing SDN, you're going to need a new set of tools. You're going to need all this IP visualization to make it work. So there'll be a whole new set of standards and tools so you can figure out what's going on, because you can't see anymore all these bits flying around. You need to be able to manage them. Okay. So this gets me to my second key slide. How then should telcos transform their networks? So there's 3 things: transformation, integration, decommissioning. Decommissioning is a really interesting one. It's one that's not being talked about very much, but let's just go through them one by one. The transformation's already happening. We've got all IP, that's already happened, there's no circuit switched anymore. Fast, low latency, that's an absolute must for video and so on. All those bits being video that we said about on the first and second slide, but the requirement of video is you've got a consistent transport. It shouldn't be too bursty, it shouldn't have latency, so very high performance network. And whether you like IMS or not, it's currently the telco solution for moving next generation voice. And you have to admit that, you know, telcos like telco-oriented solutions. So IMS, and hence RCS, and VoLTE, which is built on IMS, those are going to be technologies that people will deploy because they're available. That's the roadmap from a telco point of view. Converged access, fiber to the something, door, curb, building, whatever makes sense. I'm very pragmatic about this. You have to find a solution that works for you, your customers, your build environment, your regulations, your customers. I do a lot of consulting in Indonesia. They don't like people coming into their homes. It's a very private space. They don't like installers coming in and moving wires around. So installation is a big issue. If you can do as much as you can outside the house, they're happy. Things like this are very important. Integration, that happens anyway, because every generation of technology tends to be a superset of all the things that went before. So, for example, you know, we do a lot of fiber to the curb. Well, those multi-service access boxes, they do voice and ADSL all on the same port. It's all in the same box. It's all fully integrated, VDSL, ADSL. Multi-carrier. We want our software-defined radios and you know, form factors that give us macro radio networks that are very easy and flexible, and all on the business side, wholesale, sharing. No, owning towers shouldn't be part of your business plan anymore, for example. But the really interesting one for me is decommissioning, getting rid of all this old stuff and clearing out the balance sheet and all of the people, the equipment, the buildings, the ducts, the wiring, of all the stuff that isn't in this roadmap. And some people are now doing this. So there's a lot of obsolete technologies. I included telegraph at the last minute because yesterday they announced that the Indian postal service is now going to stop doing telegraph service. So 130 years of telegraph service is now being stopped. But there's a whole bunch of things we need to clear off. I've got a client in Philippines. They've got a frame relay box. There's one customer on it, and he refuses to give it up. So he's got an entire box of frame relay just serving one customer. And the customer doesn't even know why he's got it, but he can't turn it off because he's unsure. So legacy then, we need to address these fairly rapidly. End-to-end optimize, I'm going to go quite quickly because some of this has already been covered. We need a network that can do that end-to-end, okay? Decommissioning, who is doing it and why? Just about everybody's talking about it. This is the intention over a 5-year period, survey done by PwC. But the biggest one for me is efficiency and OpEx. That's where you're going to get really the gains. Telecom Indonesia actually claims to make a profit from it by outsourcing to a third party to rip out all of the old copper and clear out all of the exchanges. They actually reckon that the scrap value pays for itself and they actually make money from it. And they get an exchange building that's now freed up, and they can then convert it into something like a data center, which is now revenue and an opportunity. What are they doing it? Mostly they're getting rid of it. This is which technologies, 2G primarily, and wireline are the big hitters here. As soon as you can, get them turned off and scrap them and get all that equipment down. This is my last slide, and this is the one I wanted to spend a few minutes on if I have time. I have time. NBN in Australia, very controversial because of the cost, but the most strategic, the most forward-thinking of all of the telcos, in my opinion. Because these guys, follow this, they're going to do fiber to the home, not fiber to the curb of the building, fiber to the home, as much as they possibly can, and then it's going to be a bit of wireless and satellite because it's a big country. Competitors, they're buying them out. They're actually buying out the cable networks and other fiber companies and either turning them off or reusing their assets and turning them into an NBN. Buying them all out. There's going to be nothing left. So at the end, there's going to be no other competitors. It will be NBN, it will be fiber everywhere, with a bit of LTE as an overlay. And Telstra, they've done a deal with Telstra that when they've fibered up an area, if Telstra can go in and remove all the copper and they can fully pull it all out, they'll get some money for that. They'll get paid off when they fully decommission all of the copper. So at the very end game here is no copper at all. Fibre to the home, no compromises, fully flat, fully forward-thinking network. And I have to say, politics and some of the money issues aside, that's the one that most impresses me in terms of flattened networks. These guys have got the vision, and I really hope it comes out. I really hope it happens. It might get diverted over the next few years because of the election, but that's the one to keep an eye on. If you want to know where networks are going to look like, hopefully there will be one in Australia in a few years' time. Thank you very much.